This is Dr. Carroll, and this video is about generic classes. Now this is building off of my video on generic methods. So if you haven't watched that one, watch it first. So generic classes are awesome because what they allow us to do is to intelligently reuse code. Furthermore, they help us to understand like the Java collections, things like ArrayList, which is a generic class and has the angle brackets. And so it can help us understand how to write our own version of a class that is generic. So this video is pretty simple. I'm going to cover one example where we're going to see a simple class using the object class, and then the same thing using a generic class. Okay, so first let's see the object version of it. So I'm calling this pair objects. It has two fields, a first and a second. And so we can pass in, we have a single constructor to pass that in. We can assign them. We have setters. We have a set and a get for both the first and the second. And we even have a toString object here to display pair and display call toString on the first one, call toString on the second one. And main here, we're creating a string, an integer, a double, a character, and we're going to put a string and an int into pair objects, and since they are children, a string and an integer are children of the object class, then it's fine. The problem comes when we call get first and we say, hey, get something out. Well, what it gets is an object. It returns an object because we can see that from the header here, get first. It returns an object because that's what it's stored at. Now it can store anything, but we have to cast it every time, and that gets annoying. And so that is one advantage that the generic class helps out with, is it removes that requirement to cast every time. And so similarly, we could have put something else in here. We can compile this here, and sure enough, it compiles. Woohoo! And we can run it, and we can pull out the first, and we can call toString on it, which says, hey, this is a pair, hello, and 42. And this just shows that we can get different things and we can work with them. Okay, now let's see, what does the generic class version look like for this? Okay, so notice right off the bat, when we declare a class, we specify the class name, angle brackets, and then our unspecified type here. So here I'm using T1, T2 to suggest type 1 and type 2. And so that says, hey, in this class, there's this unknown type, and we're going to call it type 1. So everywhere where we need type 1, we're going to have T1. So this allows the two objects to be different. So we could have T1 here, here, and then notice even in the return statement, we have T1. And so that says for the whole class, this is now a generic class, and so we have pair, and it allows us to have different types. And notice when we have different types, we have a comma separating them. And then same thing for T2. toString is actually exactly the same. We come down to main here, it's almost exactly the same. We're creating a string, an integer, a double, a character. Now when we specify I want a pair object, we have to say, well, what kind of object do you want? Well, I want a string integer kind of pair one to specify what those types are. And notice we specify them not only here on the left, but also here after new and the class name, we specify them as well. To me, I think of them as the new type. And so our data type now is pair with string integer, and we need to specify that over here as well, just like we did with ArrayList. Notice here when we do get first, it is a string that we get out and not an object, because it knows it's a string. We come up to get first. It says, yep, I'm returning type T1, and T1 was a string. Here when we call get first, it's going to return a double because that was what T1 was specified there. So for completeness, let's see this one. Compile. Woohoo! And run, and not surprisingly, we get the same thing. So that's this brief video on generic classes. Now go and write some.